Okay, for the recording, I'm going to go ahead and repeat our objective. Our objective today is that I will be able to solve ratio problems utilizing a tape diagram when knowing a part. So in the first example here, it says Mason and Lanny ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Lanny ran was 2 to 3. So I'm going to go ahead and highlight some important details here. You just follow along with me. So we have Mason and Lanny, and what are they doing? They're running laps. Well, the ratio of the number of laps that Mason ran to the number of laps that Lanny ran is 2 to 3. Remember last time in our lesson, we talked about how we can show a ratio in 3 ways. We can put it as a fraction, we can use a colon, or we can use the word 2 like you see in this one right here. It's utilizing the word 2. Now, we also talked about how in ratios, order matters, that whatever is written first is what's being described in that value. The first number that's written there goes with that first person here that it's written. So Mason is representing the 2 laps and Lanny then is representing the 3 laps. So you cannot flip-flop those. You can't say it's 3 to 2 because that would be inaccurate. That would then be saying Mason ran 3 laps and then Lanny ran 2, and that is not the case for this situation. So 2 to 3. So who's running faster, Mason or Lanny? If Mason is running 2 laps and Lanny is running 3, who's running faster? Can you please put that in the chat? Is it Mason or Lanny? Who's running faster? Yes, Lanny is running faster. He's 1 lap ahead of Mason. So he basically lapped him and is running a little bit faster than him. Okay, let's get to the problem here. It says if Mason ran 4 miles, how far did Lanny run? Draw a tape diagram to determine how you concluded your answer. So I'm going to highlight here where it says Mason ran 4 miles, and we're trying to figure out how much Lanny ran, and we're going to draw a tape diagram to help us with this. Well, you have experience with tape diagrams from elementary school, so we're going to pull that prior information out. I'm using a pen, but I need you to use a pencil. So if you make a mistake, you're able to erase it. The first thing we do when we attack these kinds of problems is we write the label. Please say, write the label. So when I say write the label, what I'm referring to is what is it that we're comparing? We're comparing Mason to Lanny's laps. So we're going to start off by writing Mason, and we're going to write it in the form of a fraction because we're dealing with a ratio here, 2 to 3. So we're going to put the labels as a fraction, Mason over Lanny. So in your notebook, it should look like this. You should put Mason over Lanny. So we write the label. The next thing we do is we're going to write the ratio that's associated to these 2 people. And the ratio was 2 to 3. And you must remember, keep it in that order, 2 to 3. You cannot put 3 over 2. So 2 to 3. The next thing we're going to do is we're going to draw a tape diagram that goes along with our ratio of 2 to 3. Now, when we do our tape diagram, let's go ahead and do the tape diagram for the 2 first, and then I'll talk a little bit more about how we're going to do the one for the 3. So you're going to draw a rectangle, and then you're going to split that in half, and there's our 2 parts, okay? Now, when you're drawing your diagram, do the best you can to make them proportional. Now, it looks like this one's a little bit maybe thicker than that one, a little bit longer, but it's pretty close. So try to draw it to where your diagram is similar in size from one piece to the next. So for example, do not make your diagram like this. Do not make your diagram like that because you're making this section much smaller than this section, and they're supposed to be equivalent in size like this one. So this is an example of what not to do. So look at your paper and see if you did a good job at making both of your pieces about the same size. Okay, the next important step in making our diagram is on this 3 right here, that our diagram must line up with what we drew right here. So the first 2 of my 3 must line up with the first 2 of these ones. So let me show you what I mean. So if I draw my diagram, this is going to be longer, right? Because it's a set of 3. Because I want this section to line up with this section, I see my line right here. That's going to help me tell me where the line goes out on this one. Same thing here. This line right here tells me where to put the line out on this one, and it goes right there. So you can see that this first section is lined up with this first section of that diagram. This one is lined up with that one, and now all I have to do is close up this one. I made it a little too long, so I'm going to close it up there. And because I have like a whiteout tape, I can just go ahead and white out some of that on the end. So again, a couple things to keep in mind when you're doing your diagram is that you're making each section proportionally the same size. And when you're drawing your second one, that you have them lined up. That's super important, because if you don't do that in our next math lesson, you're going to see that we're going to run into all sorts of problems. It's super important that those guys are lined up. Look at your paper right now and make sure that you have them lined up. If not, please fix it. All right. All right, the next thing we're going to do is we're going to take a look at where it says if Mason ran 4 miles. Mason is the top diagram and Lanny is the bottom diagram. So if Mason ran 4 miles, that means they're telling us how many total miles Mason ran. And since it's representing this diagram right here, we're going to put equals 4 miles, just like that. Now, we need to figure out how much goes inside each box. I'm going to have you make a connection here from our prior lesson that we did last week. Watch this, you guys. Do you remember how when we used the identity property, we were trying to find the missing value in one part of the fraction? That's essentially what we're doing. And what goes inside here is the factor that we're going to multiply by to get that number that we have here. So what would I need to multiply by 2 to get 4? What would I need to multiply by 2 to get 4? And if you're saying 2, you're correct. Now remember, when you have the identity property, when you utilize identity property, your numerator and denominator need to be the same because we're multiplying by really one whole. So we would put a 2 right there. So basically what we're saying is what goes inside each of these boxes is that 2. So 2 here and a 2 there. And if you were to count by 2s, you get 4. 2, 4. Or you can be thinking of multiplication. 2 times 2 is 4. Well, because each of those is 2, and because we're utilizing the identity property to make an equivalent fraction, essentially, we then need to put a 2 inside each of these boxes. Because isn't 3 times 2 going to make 6, right? And then we go 2, 4, 6. So this equals 6 miles. 6 miles. So this is what we did last week in our math lesson, where we were utilizing the identity property. This week, we're figuring out what the answer is by using a tape diagram. Okay? So I'm hoping that you made a connection there in showing that. So the question again was, how far did Lanny run? Well, Lanny is this bottom diagram. How far did he run? He ran 6 miles. We even see it right here when we found the missing number there in that fraction, 6 miles. So in a sentence, we're going to say, Lanny ran 6 miles. There's our answer, guys. Lanny ran 6 miles. Okay, any questions so far? Yeah, Tyson, you gotta make sure you do the diagram, buddy. Okay, you gotta do that, because in the directions it says to use a tape diagram. Okay, Brianna, I'll wait just a little bit. So in elementary school, you should have been making tape diagrams. The word 2 in like 2 to the to 3 is not like a multiplication sign. You could think of it more of like a dividing sign, right? Because remember, we can write it like this, 2 to 3. So you need to think of the word 2 as more like a dividing sign. Okay, let's go on to the next one. So in your notebook, go ahead and put B. So you did all of your work in your notebook, and then now you're going to put a B because we're going to do the second part of the question. All right? So B, if Lanny ran 930 meters, how far did Mason run? So we have 930 meters for Lanny, and we're trying to now figure out how much Mason ran. Again, we need to use a tape diagram to demonstrate how we conclude our answer. So again, we're going to start with our label, Mason over Lanny. Now you might be thinking, hey, wait a second. They said Lanny first. Shouldn't we put Lanny first because order matters? Well, the thing with this is we're going to put it in the way that it was mentioned in the story problem at the beginning. So we're not going to change it up because they decided to put Lanny first in the actual question. We need to keep it in the same order that they wrote it in the story problem. Okay, so we're going to do Mason over Lanny again. Please write that down. Mason over Lanny. So this is, you should be doing this in your notebook right next to B. So it would look like this, Mason over Lanny. Okay. Then we're going to put the ratio that's associated to it. It's 2 to 3. 2 to 3. Next, we're going to make our diagram again. Now, just like the last one, you need to make sure that your pieces of your diagram are equal in size, the best that you can do on that, and that your sections are lined up. So I'm going to do my 2 here, and then my 3 here. Okay, so these 2 on my 3 need to be lined up with these 2 on my 2. It's so important that you do that. Please, please make sure that you are following that rule, that you are lining them up. I'm telling you, our next lesson is going to be it's going to be vital that you do this for our next lesson. So we need to do it now. Okay. All right. So we have 2 to 3. If you need to fix it, please fix it. Okay. Now it says if Lanny ran 930 meters, how far did Mason run? Okay, so we're looking at Lanny now. Lanny is the bottom diagram. So right here, we're going to put equals 930 meters. All right, so this, to make a connection from our prior lesson, would look like this. 2 over 3 equals what over 930? That's basically what we're doing, okay? So we have 3 sections here. If we have 3 sections here and all 3 of those equal 930, wouldn't it make sense that we need to divide the 930 by 3 to see how much would go in each one of those? Yeah, so I'm going to do a little thinking bubble here. 930 divided by 3. Now, whenever we're dealing with larger numbers, and it's a little bit harder to do it mentally. This one you can do pretty easily mentally, but in the cases of times when doing it mentally is a little bit harder to do, I am okay with you using a calculator because I'm not teaching you how to divide. I'm not teaching you how to multiply. Those are all skills that you should already be really comfortable with. And I don't want it to bog us down in our lesson. So when we get to situations like this, we can simply use a calculator. So if you have a calculator, you can definitely use it. But for this, I'm going to do it mentally because I can see that I can do that. How many times can 3 go into 9? 3 can go into 9 3 times, right? Because 3 times 3 is 9. How many times can 3 go into 3? It can go into it 1 time. How many times can 3 go into 0? It can go into it 0 times. So it's 310. If you were to do 310 in each of these boxes, and you were to add each of those up, you would get 930, wouldn't you? This is the same as doing 310 times 3 to get 930, think about fact families, right? Remember fact families? You did fact families starting in first grade and on to second grade and all of that. So we have 310 times 3 makes 930. Okay, so if basically what that's saying then is if we were to multiply this one by 3 to get 930, we would also multiply 310, excuse me, 310, then this one also needs to be multiplied by 310 2 times. So over here, we're going to put 310 in each of these the 2 times. And what is 310 times 2? You can do that mentally, can't you? Yeah. You can think 300 plus 300 is 600, and 10 plus 10 is 20. So we know that that's 620, and we need to put our units meters. 620 meters. And if you look up here, if you did 2 times 310, doesn't that make 620? It sure does. This is showing it using calculations. This is showing it using a diagram. So this is through calculations. This one is using a diagram. The directions said that we had to use a diagram. Yeah. Okay, so our answer is 620 meters. So in a sentence, we're going to say Mason, right? Mason ran 620 meters. So Mason ran 620 meters. Mason ran 620 meters. If you get a story problem like this in your homework, you don't need to write out the sentence. You can just put your answer, 620 meters. Does anyone know, I could turn the light on that, see if that helps a little bit. Does anyone know the abbreviation for meters? Can you put it in the chat if you know the abbreviation for meters? I need to plug my computer in, so you put that in while I'm plugging it in. Yes, good. It is an M. M for meters. Nicely done. Okay, let's go to the next one. So let me pause for a moment. Are there any questions before we move on? Okay, so then in your notebook, go ahead and put a C. This is the next part of the story problem. So C says, how far did they run all together? So I am going to assume that this is talking about the prior question that we just solved. So all together, whenever we see all together, we should be thinking, oh, I need to add, right? I need to put them together, which then means I need to add. So we're going to add the 620 meters and the 930 meters together. So we have 620 meters plus 930 meters. All right, let's do this mentally. What's 900 plus 600? What's 900 plus 600?
1,550.
You jumped a little bit ahead of me. You already added the 20 and 30, so hold that thought, okay? So we're just doing 600 plus 900. 600 plus 900 is 1,500, right? Plus we have this 30 and 20. So 30 plus 20 we know is 50. So this is going to be 1,550 meters is what they ran all together. 1,550 meters. Okay, any questions about that? Okay, in your notebook, go ahead and put example 2 and then put an A. Yes, go ahead, Ethan.
I wasn't finished the last part.
Okay, there you go. All right, so we have a little bit more time. We'll be running over just a little bit, so just hang in there with me. We're going to do one more example. Josie took a long multiple choice end of the year vocabulary test. The ratio of the number of problems Josie answered incorrect to the number of problems she answered correctly is 2 to 9. So the first thing we need to do is highlight our important details. That's so important. That's a good skill to have that you're doing regularly and just becomes natural. So we have Josie who's comparing her incorrect problems to the problems that she got correct, and that ratio is 2 to 9. So for every 2 problems that she gets wrong, she's getting 9 correct. So that means she's getting more right than wrong, which is good that it's that situation. Can I flip it and say 9 over 2? Yes or no? Give me a thumbs down if no. Give me a thumbs up if yes. Right? We cannot, right? We cannot flip those and say 9 over 2. We have to keep it 2 over 9. All right, the question says, if Josie missed 8 questions, how many did she get right? So we're talking about missed questions to questions that she got right. Draw a diagram, a tape diagram to justify your response. So remember, the first thing we do is we write the label, right? We write down what is being compared. Well, what is being compared? Is Josie being compared to something? No, it's the questions she's getting wrong and right is what's being compared. And if we look up here in the story problem, it's incorrect to correct. So that's what we're going to write as our label. Incorrect over correct. Incorrect to correct. Now, what was that ratio? It was right here in the problem right here, 2 to 9. So we're going to write 2 over 9. The next thing we're going to do is draw the diagram. So we do label, fraction, diagram. So we're going to, one thing I noticed is I have a 9 right here. I'm going to be making a pretty decently long diagram. So be careful that you're not making it too big because we want it to fit on our page. So maybe this diagram, I might make it a little bit smaller than my other one that I did on my previous problem. So there's my 2 parts. And now I'm going to do my 9 parts. Now remember, the first 2 of my 9 must match these first 2 and keep them equally sized pieces. So I think I'm going to do my 2 first, and then I'm going to extend it to figure out how I'm going to do my 9. So I have 2 there, 3, 4, 5, 6, 7, 8, and 9. So there's my 9. They're not perfect, but it's pretty good. I mean, they're just about the same size as each other. Another good tip is to count and make sure that you put the correct amount. So I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 there. All right, now I can go back to the question and see what I'm dealing with again. If Josie missed 8 questions, so she missed 8. That's something that they gave me. They told me the 8 questions, what she missed. Is that going to go to the top diagram or is that going to go to the bottom diagram? If it's missed, which one is representing the missed problems? I want you to write in the chat, top or bottom. Yes, it's the top. So we're going to put equals 8. Now, if those 2 together make 8, what do each one have to be? You should be thinking, oh, I just need to do 8 divided by 2. And what is 8 divided by 2? 4. That's right. So that means we're going to put 4 inside each of those. And because we're using the identity property, essentially, that means each of these also has to be 4, right? So we're going to put 4 inside each of these here. So to activate your prior knowledge again, think about it like this. 2 over 9 equals 8 over what? And what do you have to multiply by 2 to get 8? Yes, 4. And over here, 4. Look, guys, there's 2 4s. Aren't there 2 4s right here? Yes. Look right here. There's 9 4s. Are there 9 4s right here? There sure are. See that? This is using calculations. This is using a diagram. All right, so we're now thinking, okay, 9 times 4. What's 9 times 4? 9 times 4 is 36. right? 36. So our missing piece was 36. So 36 and 36 questions correct. The question again asked, how many did she get right? We can now answer. We can say she got 36 right. So in a sentence, I'm going to say, Josie got 36 questions correct. Josie got 36 questions correct.